everyone. Welcome, bienvenue to the cyber defense stage. My name is Laura. It's my pleasure to host this next panel. It is cybersecurity and the fourth industrial revolution, where we're going to explore new challenges and opportunities of operational technologies in what is sometimes referred to as Industry 4.0. But before we begin, it is my pleasure to introduce Derek Harp, founder and chairman of Control System Cybersecurity Association International, to say a few words on the topic. Take it away.
Thanks. I'll just take a couple of minutes. I'm excited about this panel because a few of my longtime colleagues in the United States are here to talk about this today. And so let's talk about what Industry 4.0 is very briefly, and the fourth industrial revolution. It begs the question that there must have been a first, a second, and a third if there's a fourth. And so I'll just go a little down history's journey with you guys, a little down that path. The first generation, our first industrial revolution, is in the 1700s, and it's really about power. It's about steam. If you think of things being animal and human powered before that, and then water powered, and water powered was good. If you had a mill, you'd be near a river. It might freeze up in the winter. So you imagine going to steam was a giant step forward. It was transformational. You could run a piston or some sort of device pretty predictably, potentially indefinitely. Early technology and all these revolutions, the early technology was dangerous. Safety needed to be introduced, so there's always been these costs. And that's certainly going to be part of today's theme when we get to this fourth generation. But it was a giant step forward. You could produce something more predictably, and you could locate your factory wherever you wanted. The second generation, or the second revolution in the 1800s, introduced assembly lines and mass production. It's like, you know what, now we can power a conveyor belt, we could have people doing discrete tasks, and they can do their part and send the part on to someone else. And what does this do? It brings down the cost of goods that might have been hand-produced prior to that. They would have been much more manually intensive. That's a theme that also is going to keep playing out. So that's great for consumers, for people to be able to get some goods maybe they couldn't have afforded before. And it's powered by that first industrial revolution, right? They all build on each other. Electricity enters into the scene in the 1800s. The third revolution is more recent, and that's computers and electronics and programmable logic controllers. So we're talking more recent history, although this has been going on for a while. And that gives us some more automation and some more control. It gives us visibility to certain things. Obviously, robotic mechanisms have been added now for some decades to various processes. And again, increasing our efficiency, decreasing some of our costs. So what is this fourth generation? And I'm not here selling it, even though I can get excited about it. It's got dark side to it, not just cybersecurity, but replacing human beings with automation, with robots. So not getting into the challenges of it, there are a lot of positives. This is the complete integration of technology and human beings and data. This is what Industry 4.0 is. And when all that gets aligned, truly connected, what do you have? You have data transparency. You can see if your CRM and your ERP system and your floor operation systems and your customers, if all of that is integrated, you can increase speed again, you can increase customization, you can decrease waste. Susie can order a 43-inch by 66-inch red widget from Acme Company and push that button in her home office and have it on her doorstep, the next morning. That's enabled by this process we're talking about. And when your whole supply chain's, all interconnected, you can see where everything's coming from and whether you've got enough ingredients and enough orders, and that you can really decrease those timelines. There's dark sides to it, right? And obviously this panel is going to talk about one big aspect of that. If all that data is there, someone disrupting it for profit is a great opportunity. We've already seen that. And the more we become reliant and the more we attach all these items and increase what we would call attack surfaces, the more opportunity for someone to get in there and say, if I take some of that away from you, you're going to have to pay me. Also, our intellectual properties in there. How we assemble, the order that we assemble, the ingredients, the types of things that we create. Maybe a screwdriver manufacturer, maybe that matters less, but you can think of a drug pharmaceutical company, that might be very critical. How all that is assembled, that's great intellectual property for someone to siphon out of there. So it's not just about making something not work or disrupting the process, it may be also examining the process for profit or for gain. So I'm excited about what's to come and the things we can do, but we have to go into it with a mindset of that it's not free. There are prices we're going to have to pay, and one of them is secure by design. Anything new, we have that luxury. Let's make sure that now we can build these systems with security in mind. So a great panel and moderator that's going to cover cybersecurity for Industry 4.0 for you. Thank you.
Thank you so much, Derek. Now I have the privilege to be joined on stage by leading edge experts who will help us unpack how to embrace and integrate cybersecurity at the heart of this revolution. It's my pleasure to welcome to the stage Renee Sylvain Bedard, who is president of Indominus Consulting, author, podcast host, and VP Industrial Security at Waterfall Security Solutions, Andrew Ginter, and Patrick Miller, who is owner and CEO of Ampere Industrial Security. Welcome to the panel.
Thank you for having us.
Of course. So everyone can hear us, right? We're good? Yes, I got a thumbs up. Great. I'd like to start with a few quick introductions. You can tell me who you are, what you're working on. Let's start with you, Renee.
Well, thank you. So my name, as she said, is Renee Sylvain Bedard. I own the Indominus Group, and we are specialized in cybersecurity, cloud, and we're actually moving into managed security services as of next year. And I've been in IT for the best part of 25 years. And most of this has included cybersecurity, so I've seen many aspects of the job. And long journey within CGI as well. So I've been roaming through international clients such as Bombardier Aerospace, some nuclear agencies, and banks. So lots of security on all of those.
All right, Patrick, want to go next?
Fantastic. I'm Patrick Miller, owner and CEO of Ampere Industrial Security. We are an industrial security consulting firm. I'm a former regulator in the U.S., call myself a recovering regulator. I was one of the architects of the NERC CIP standards for the power sector in North America, and been an old utility guy, telecom, water, electric, so understand the OT and ICS world quite well.
Great. And finally, Andrew?
Sure thing. I'm Andrew Ginter with Waterfall Security. At Waterfall, I lead a group of subject matter experts who work with the world's most secure industrial sites. Before Waterfall, I developed control system product for a decade. I developed IT/OT middleware that connected a lot of control systems to IT systems and thereby contributed to the cybersecurity problems that now plague many industries. I got religion. I wound up Chief Technology Officer at Industrial Defender, developing the world's first industrial SEM. And now I'm at Waterfall, the author of a couple of textbooks on industrial security, and the co-host of the Industrial Security podcast. It's a podcast about security, not about Waterfall. Mr. Miller's been a guest, and I look forward to Renee joining us.
Great. So just so we're all working with the same definitions, I'd love to hear your views on the fourth industrial revolution and the current moment we find ourselves in. So we can start with you, Patrick. What's your sense of where we're at, how close we are to this revolution, and is there anything that's exciting or worrying about it for you?
Yeah, in my perspective, we're there. I mean, not that we're done, right? But we're well into it. So we're not. I would say we're not even at the middle yet. But it's not just about to happen or starting to happen. It's happening right now. We're seeing everything from IoT, IIoT being, well, the reality is you can't buy analog equipment anymore. So if you go to buy equipment in a plant, whether it's a manufacturing facility, a water facility, a gas facility, anything you buy is digital. Like, you just can't buy the analog stuff unless you go to eBay, which some still do because you have to. But with that, since everything you're buying is digital, it all creates data. It's all going to be connected. So everything that you couldn't do in the past, you can do now. Your ability to take what was a refrigerator-sized RTU is now something the size of an iPhone, and we'll do what will 10 other devices will now fit into that same form factor. So this is not something that's going to happen. It's already happening. So the question is, how do we catch up to it, because it kind of got out ahead of us a little bit.
Okay, Andrew, anything to add?
I'll agree with Patrick that we're there. We're seeing on the sort of the manufacturing side, we see a typical factory has 50 kinds of connections into cloud services, pushing 100 maybe. Even in the most conservative industries, I'm thinking process, think power gen or refining. We're seeing connections out to the cloud. It's something that's happening. A lot of people are concerned about what does that mean, especially on the OT side. The process industries are, what's the right word? They're not, I don't want to use the word laggards as it has a negative connotation. They're much more concerned about the security risks, and so they are more cautious in their adoption. Yes, but we're seeing everyone doing it.
And I would go a bit further down the line, which is all those 100 connections to the cloud. are feeding in data lakes, which are being used for AI, for machine learning, for digital twins, and that enable faster decision, predictive analytics. All those things we already see happening, but make a big difference in the way we operate industrial complex today.
Okay, so we're here. Let's talk about some of the challenges. Of course, in 2022, we're facing examples of takeover, alteration, destruction of increasingly connected facilities. In your estimation, what are the most critical issues facing security and risk leaders in the short, medium, and long term as we're staring down the barrel or very much in already side of this revolution? Let's start with Andrew.
Sure. Where to begin? In my books, I mean, there's a lot of people out there who are saying we have to protect the data. How can we protect the data if it winds up in the cloud and someone else is storing it? To me, that's not what I see my customers most worried about. My customers observe that all cyber sabotage attacks, and it's sabotage they're primarily concerned with, all cyber sabotage attacks are information. And any piece of information that comes into our network is potentially an attack. This is the nature of cyber sabotage. And so what they're worried about is a Kaseya-style attack. This was an attack a year ago where ransomware took over a cloud-based security update server. So people were connecting to the cloud to take advantage of this service and distributed ransomware, I was told, in the space of like 45 minutes to something like between 1,000 and 1,500 victims.
8,000.
Sorry?
8,000.
8,000, okay. Thank you for that. To me, this kind of compromise is inevitable in the OT space. Imagine, I mean, if we've got a plant with 100 connections, or connections to 100 kinds of service providers, will all those service providers be at the same level of security? No, there's going to be poorly secured ones, there's going to be well-secured ones. Tackle one of the poorly secured industrial cloud service providers. Take over their cloud service and use it to pivot an attack back into the IoT devices on the industrial network. Now you can pivot through the devices by updating their firmware and target dozens or 100 power plants or pipelines or rail systems at once. This is a disaster waiting to happen. This is what I see my customers worried about.
Okay. What about you, Renee? Any challenges you're concerned about?
So my customers have a slightly different point of view, but I understand where you're coming from, and it makes sense. They're actually afraid about downtime most of the time, especially in the health sector and some of the agricultural sector. Downtime for them means either a loss of crop or a loss of life in the case of healthcare. What I do bring them to see, though, is that further down the road also is that the data that's bringing in this those systems are now building to decisions. So if someone corrupts the data coming in, even though you tell me, well, nobody's interested in my metrics or what's coming out of my, but if that metric is being used to make an important decision or a life or death decision, and someone corrupts it along the way, it's still vandalism or it's still cyber criminality. So you have to be mindful also of where that data is going and how that data is protected.
Anything to add, Patrick?
Yeah. One of my biggest concerns is we're meshing all of these things together that weren't connected in the past. And we're connecting more and more things to more and more things. So we end up with situations where we have so many interdependencies between the actual physical thing that we're trying to do and then all of the other technology components that swirl around it, from the business side, customer interaction, all the way down to the thing being done. So I look at, best example, of course, is the Colonial Pipeline incident, where they had to shut down operations because of some IT things, and they had dependencies on the OT side. So these infrastructure components or elements that we want to continue, whatever that might be, those things are now dependent on so many other little components around them that the ability for operations to go into what I call turtle mode. So if they got ransomware, how could they effectively lock down a shell, keep something moving, whatever critical thing it is, whether it's downtime or loss of life or pipeline operations, you name it, and still operate through the situation? Because it's not, we're now at a stage where everything is digital. I mean, We have digital toothbrushes. Everything is digital. It's insane. So when we're at that level on a business scale, at the reach that we've got, which pieces of that can you actually let go? So I think of like an automobile has basically crumple zones and a shear away drivetrain. How do you design this system in a way that, yes, you can run head on into something and your business can still survive?
We've been talking about different components, and my next question has to do with the human component. Given the evolving threat landscape and the interconnectedness and complexity of all of this, how are you advising chief information security officers to adapt and architect security in this transformation? It seems like we're building the airplane as we fly it, so where should they be focusing their efforts? And anyone can jump in.
Okay. The first thing I would say to the CISO is make sure you simplify and not complexify the environment.
Okay.
And that means usually working with the IT architect team and the OT architecting team to make sure that you don't bring in 20 tools to fix security. You need a limited number of tools that you master, especially with the current talent shortage. You cannot go into 20 different tech because they're the 20 best of breeds. You need to have one or two tech that you master. And that way, when there's an anomaly somewhere, A, you'll know, and B, you'll be able to dig in much deeper into that anomaly than if all you do is use the 1% top.
I know what you have. Start. I mean, it's silly, but it seems to start with asset inventory. If you don't know what you have, you don't know what to protect. I'm not saying inventory everything, but you know what is critical to you. If you have to do things formal like a business impact analysis, that's great. But you in a business, you know what the important stuff is. Inventory those things, and then monitor the heck out of those things. Look for anomalies. But if you don't know what you have and you're not watching what you have, good luck. I mean, but you got to start somewhere, and that's a good place to start. From there, you can design what you're going to do in terms of reactivity, recovery, all of these things, whether it's incident response or recovery if you need to. But things like ransomware, other disruptions are simply going to happen. And if you don't know what you have and you're not watching, you really, good luck at best.
Andrew.
Yeah, so I guess my first piece of advice to people who are managing other people or recruiting people into the space is to be careful of, what's the right word, the predisposition of the people you're bringing into the space. Let me, concrete example, I don't have hard numbers, but back of the envelope suggests that there are 50 times as many security, IT security experts in the world as there are OT security experts, 50 times as many. So if you need a bunch of security experts, and you grab people, you're probably going to get a bunch of IT people. Now, there's nothing wrong with IT people other than they don't really know what they're getting into. You need to get them trained. You need to bring them up to speed on this, what appears to be a very similar domain, because a lot of the high-level architecture of control systems uses Windows and Active Directory, and so it looks very familiar, but in fact, the consequences are different. Concrete example. I mean, there's so I'll give you an example in just a second, but the second point I want to make is the field is still evolving. 2 months ago, the U.S. Department of Energy put out a report on a strategy for cyber-informed engineering. What is that? It's something that does not exist in the IT world. The example that I give that illustrates it is, imagine you're a technician who's keeping 4 boilers in a coal-fired power plant working. Each of these boilers is 5 stories tall. If it blows up in your face, I'm sorry, we're dead. Everyone in the blast radius is dead. We never see our kids again. And if you misoperate the furnace, there's a risk that you're overheating and overpressurizing the boiler. Now, if you're that technician, if we are that technician, and we have a choice, we want to prevent cyber sabotage from overheating the furnace. If we have a choice and we have to choose between a mechanical valve that when the pressure is too great, the valve is forced open, the steam escapes, and the boiler cannot explode. There's no pressure in it anymore. It's got a pin here. You break the pin, the valve is open. You got to replace the valve to repressurize the boiler. We have that as an option, and we have a longer password on the device controlling the furnace. Which would we prefer? I'm sorry, I'd prefer the valve. Here's the thing. In the NIST cybersecurity framework that everyone cites, identify, protect, detect, respond, and recover, where's that valve? It doesn't exist. Okay, it's not an IT security mechanism. It legitimately does not belong in the NIST framework, but it is an engineering mechanism for controlling cyber risk. To Patrick's point, if the plant is compromised, there are certain consequences that should not be physically possible. Truly unacceptable consequences should not be computer accessible. And it's more complicated than that. People generally have layers of protection. There's going to be a computerized safety system in there, but there's going to be another layer of protection, a last line of protection that is an engineering protection. And this is the kind of stuff, this body of knowledge does not exist. The strategy says we need to create this body of knowledge. Yes, we do. So A, the space is evolving, and B, the IT experts we bring in need to become aware of the bigger picture.
All right. So with that, I'm curious, there's probably some folks in the crowd who are entering the field, and we were talking, to the chief operating officers, but what messages do you have for the next generation about the evolving space and the transformation that is ahead of them? Where should they be putting their skills and their energies? Anyone can jump in.
This is going to be, how do I put this in a kind way? This is going to be generationally dependent.
Okay.
Digital natives are a lot more comfortable in this space. So the younger people coming into these territories have been in contact since they were children. Like, some of them read books, but many of them had iPads. And I've seen kids that the first time they went to a book, they tried to pinch and zoom on the paper.
Yeah.
So the digital natives actually will treat technology very differently.
Yeah.
And to Andrew's point, we're using technology to control really important things that can blow up and kill people. So that degree of comfort has to be balanced with the consequence with which you're acting. So I think most of it isn't training them on the technology. They'll know the technology. It's just training them on the behaviors that can and cannot cause greater degrees of consequence. So training the people for this, it's just a matter of education on, don't do these things, don't be as comfortable in these systems than you are in the others. But there's plenty of opportunity in OT security. We need lots of people, so all of you, please come work for the OT security places. We're dying for people. There's plenty of IT security people out there, but the OT side is just starving for talent.
Okay. Anything to add?
And in the same line of thinking, I believe that apprenticeship is something that has to come back into a fashion. There's a lot of older generation which have the knowledge, have the skills, know about those mechanical valves that need to pass down that information. We can no longer afford to be enclaves and just say, oh, I'm protecting my job or I'm protecting what I know. We need to go into a sharing model. We need to be mentors to the next generation.
Yeah, let me put in my pitch. Let's look at what we've been doing for the last 30 years. For the last 30 years, we have been deploying more and more automation.
Yeah.
All the modern automation involves CPUs. All CPUs run software. I wrote software for 25 years. I'm sorry, every piece of software I ever wrote, and we held ourselves to very high standards, every piece of software I wrote that all my colleagues wrote had bugs in it. And some of those bugs are security holes. This is the nature of the beast. Software is a very complex beast. And so for 30 years, we've been deploying more and more targets full of vulnerabilities for cyber attack, targets for cyber attack. And modern automation, data in motion is the lifeblood of modern automation. And again, all cyber sabotage attacks are information. Every information flow can encode an attack. And so for 30 years, we have been deploying more and more targets, and we've been connecting those targets and thereby increasing the opportunities to attack those targets cyber-wise. Does anyone see any of these trends reversing in the next 30 years? I don't. The cybersecurity problem is going to become much worse before it gets any better. Anybody entering this field has got, guaranteed employment, I suggest, for the next 30 years.
All right, so we've talked about the chief information security officers and those who are up-and-comers. I'm curious about teamwork and how cybersecurity teams can work better across industries, especially large companies to elevate security importance? And how do you propose enterprises cultivate resilience in Industry 4.0? Patrick, you like the word resilience, so I'm going to start with you.
I do, yeah. The resilience, in my definition, is the ability to operate through the attack.
Okay.
So continual operation. This takes a combination of the humans and the machines, and we've automated, as Andrew mentioned, which creates what I call the automation paradox. So the more automation you introduce, the greater the impact of the single human action. So when someone finally does step in and the human is involved, then the action has a much greater impact because of all the automation. So I think from a teamwork perspective, we're automating more, which puts more dependence not on the automation, but actually on the humans. So having the humans understand, like I say, the consequences of what they're doing and what they're getting involved in. In IT, I mean, if email goes down or e-commerce site goes down, you're losing money. But in the industrial side or the fourth industrial revolution, bigger problems can happen, such as like machines go boom, and that's a big problem. So I think that the teamwork element, I don't know, the human component, again, understanding just kind of the gravity of what you're doing and what you're getting into, because it's going to be heavier than just emails down, networks down.
Renee?
And I totally agree. I couldn't have said it better. The only thing I would add is that teams now have to merge, in my point of view. So OT and IT have to merge into a single team, mainly due to talent shortage, but also to bring in all that business knowledge or that manufacturing knowledge into cybersecurity. So you can't just say, we'll have two teams anymore, or we'll have two sets of tools to do the same thing, because you don't have the knowledge, or you don't have the depth, or you don't have the staff. So one of those three will make you vulnerable. So when it comes to teams have to merge, and ways of doing things have to merge as well, and common understanding of what's at stake. I mean, we're talking about, lives or things going boom. So in order to prevent those things, the more the people know about them, the better it is. So if you have 2 teams of 5, make 1 team of 10, and make sure the 10 knows where's that valve,
Okay. We've talked about a lot of scare. Oh, yeah, please jump in first. Yes.
If I can jump in, I'll briefly repeat my point that we need the teams to be, aware of each other's expertise, the people who come out of the operations, the people who come out of IT, and respect that. But I wanted to speak to resilience as well. I agree. Ideally, our physical operations can continue operating even if the computers are compromised. Computers, especially in critical infrastructures. I mean, a small shoe manufacturer is a different animal. But in critical infrastructures, the computers should be essential to efficient operations, not necessarily basic operations. And to bring that about, I wanted to point out that one of the fields in this emerging security engineering body of knowledge is network engineering. And, we're talking about connections to the cloud. How can we prevent precisely the kind of, pivoting attack that I described? There's many techniques, but let me give you just one of them. The Electric Power Research Institute, EPRI, published a report 4 or 5 years ago. They were asked, how can we safely monitor the vibration on our steam turbines or our natural gas turbines? How can we monitor them out to the cloud? How can you do that without putting the entire operation at risk? And they came out with a report that said, look, use a little network engineering. Get the industrial Internet of Things sensors and do an engineering study. Convince yourself that these sensors are truly monitor only, that they're physically incapable of modifying the physical process. Okay, now what? Now, connect the sensors on their own network. Do not put them on the control network. They're sending information out to the cloud so that the turbine artificial intelligence can correlate all the information and say you've got a problem on generating unit number 3. If you want, some of these sensors have cell phone chips built into them. Put them straight out on the internet. Send the stuff to the cloud, because you've proven, engineering-wise, that they cannot affect operations. And, of course, you have to do the IT study to say, if the information is damaged on the way out, are the worst-case consequences acceptable? Yes, maintenance on the device is delayed 3 weeks, but, it's not going to blow up in our faces. Okay, in that case, put them on their own network, send them out to the internet, go wild. Do not host them on the control network where a pivoting attack can come back. Stuff like this is what's being added into the security engineering body of knowledge, and this is what everyone needs to be aware of on both sides of the team.
Great. So we've talked about some scary stuff, but I'm curious what opportunities and perhaps more best practices you've also seen around the corner coming up in the space of Industry 4.0. What is exciting to you or hopeful for you about the opportunities that are ahead of us? And anyone can jump in.
Well, fine. I'll be the bringer of good news. I
Yeah,
like
we
that.
need good news.
So what I do like the most is that the advent of cloud computing actually brings in trillions of signals. So we can actually see threats coming in much faster. We have, heads up before they actually are. And some of our connected system actually are made aware of threats before they hit them. So to me, that's very good news. And also, we can see that all the newer startups that are coming up are now cybersecurity aware. So we have things like AgTech that tells me, by the way, yes, we know about protecting data. We know about protecting connections. So they're into it. They're not perfect, but they're already one step ahead of the former generation. And to that, I'll add also that the new laws in Quebec are actually protecting data a lot more. So that will force companies to actually look into their data sets and actually realize what's important, what can kill them financially, but also what needs to be protected more.
Okay. Do you have anything to add?
Sure. I mean, a couple of things. On the one hand, I'm excited by security engineering. It's an emerging field. I just wanted to sort of go one level deeper. To me, and the field hasn't been defined yet, but to me, what belongs in the field is at least safety engineering, because this is a long proven space. We talked about the overpressure valve. Automation engineering, designing the automation so that we can have manual fallbacks, we can be resilient, and network engineering so that we can prevent the attacks getting to us in the first place. Because it's great to say we can detect, respond, and recover, but that all takes time. Yes, we need to be able to do that. Don't get me wrong. It's just that we cannot forget that preventing attacks with unacceptable consequences is where we start. So one of the perspectives the OT people bring to the combined IT/OT team is the focus on safety first, and for critical infrastructures, reliability second. Keep the lights on, prevent the attack from impairing operations in the first place, and then secondarily, yes, of course, we can only optimize what we measure. We want to optimize our security posture. We have to measure it. We have to be able to respond, in the worst case. So, a little of both, I guess, is what I'm arguing for.
Okay, I'll round it out. We now have the capacity, the capability to see so much more information about what we're doing. So now we have everything from basically there's literally digital dust that can give you environmental sensing in the nano-sized particle with a signal. So we have unlimited capability now. With this, we can understand how to make things better, how to make things more efficient. So it ends up with this kind of feedback loop where we're using the information and the technology to make more and better information and technology. So AI, ML, all of these digital twins you mentioned, I can now take anything, manufacturing process, geothermal plant, and I can clone it, and I can make 1 million of these clones and run 10 million scenarios and find out which one is the best under that circumstance or in that way. So we are literally unbounded at this point. The only problem is that data has to be secure, and so do the operations. So the capability for us to go in such an amazing new direction is there, but this also comes with some very significant consequences. So the promise of all of this beautiful new future is dependent upon us doing our jobs. So please rise to the challenge.
Great. My last question before we open the floor to some questions from the audience is actually also for you. I'm going to pick on you as a recovering regulator.
Oh boy.
But where do you see the role of regulation in this revolution?
Necessary. I mean, I don't like regulation, even though I was a regulator and I wrote regulation. In most cases, it's a bad idea. It's a knee-jerk reaction because something bad happened and we're like, oh my God, make a law so that that'll never happen again. And that's not the right thing to do. Regulation should be designed so that basically you must be this tall to ride the ride. And it's a minimum, it's a floor. It's the minimum thing that you're required to do. So regulating to a standard, like pick a standard that is designed by a standards body. Standards bodies are really good at what they do. They write standards. That's their job. They're NIST, IEC, there's a whole bunch of them out there. Regulate to a standard so that you're not having to change the regulation as the technology changes. The standard changes with it. So there are ways to do regulation smart. Fast, knee-jerk regulation is a very bad idea and never support that. Regulation to a standard can be a little bit more future-proof if possible, but it is necessary so that you don't have people realizing all of this fantastic potential and racing forward in a very irresponsible and frankly unscrupulous or money-driven way. So it's got to have some balance. But I would say it's not a bad idea done right.
Okay. Anything to add? Anyone else? Are we?
I'll add. Most industries hate regulation, legitimately so. There are exceptions. I was talking to a gentleman who works in the maritime industry. He says the shipping industry is so incredibly price competitive. Everyone knows they ought to do more security, but they don't dare because it will make their offerings less price competitive than their competition. And so what they want is regulation to make everyone do what everyone knows they need to do. So that's, to me, that was unusual. Most people hate regulation. To reinforce Patrick's point, at Waterfall, we had people come to us a couple of years after NERC-CIP. After NERC-CIP version 5, which was a complete rewrite of the regulation, was well and truly and auditably done. They came back to us and said, talk to us. And we said, sure, we'd love to. I'm curious, though, we called on you 2 years ago. What's changed? And they said, well, back then we were in the throes of the NERC-CIP version 5. That is now well and truly done behind us. Now we can think about security again. You know, so regulation doesn't always have the effect the regulators expect, especially, I mean, NERC-CIP was designed by the industry. A lot of other regulations, we saw the TSA impose pipeline regulations. A lot of, we saw the TSA impose rails regulations. They come from outside, and again, I need a bunch of security experts. They grab a bunch of security experts, and they're not necessarily well-versed in the industry. So that's sort of the one side, reinforcing Patrick's message. On the other side, everyone thinks it's a boring topic, but let's talk risk management for a moment. If there's an incident at one of our plants and 3 people die, and there's going to be an inquiry, there might be a lawsuit, there might be, we as security experts responsible for the plant might be called onto the stand to testify. The question that the judge or the lawyer is going to ask us is not, did you comply with the standard? Did you comply with the minimum the standard required? Did you comply with the minimum the regulation required? That's not the question we're going to be asked. The question we're going to be asked is, did you do, in this circumstance, what any reasonable person would have done in a similar circumstance? That's the standard we're held to. And often that standard is higher than the minimum. The judge is not going to ask, did you do the minimum the law requires? They're going to ask, were you reasonable? And so the advice I give people is, look at what's reasonable. Often it's higher than the minimum. Sometimes it's actually simpler than the minimum. Simpler to be more secure than to be minimally secure, with all of the loopholes and stuff you've got to fill being minimally secure.
I would.
There's also a point that most regulators miss when they design a new legislation, and that is, how will this law be used against the company? I've seen laws come on board lately where I can actually imagine a cyber criminal coming in and say, oh, by the way, don't declare it, I'll charge you $500,000 less than the government will. It's a new blackmail form. It's called extortion mechanism, and they're using that profusely now. So we have to be careful with the legislation we put forward.
Okay.
I wanted to add one more thing.
Yeah.
Other influences, in addition to regulation and, of course, motivators like crime, will be insurance. Because the insurance companies, basically, they model our risk for cyber insurance based on like 1990s hurricane models. For real, that's what they had. Of course, they lost it. they bet on this, and we took them to ransomware. Basically, just ate up all that money. So they're backing off now, and the ability for you to get cyber insurance now is very, very difficult. So we look at things like if you want to get fire insurance, well, there was a lot of fire that caused a lot of damage. Well, now you have to have sprinkler systems, building codes, regular inspections from a fire marshal. You've got to have smoke detectors. Fire extinguishers at every corner, signs that say how to exit. We don't have that yet, and we're getting to that stage. So, but that was driven by the insurance industry. It wasn't driven by regulation. So there are other drivers.
Yeah, let me reinforce that. A big factor in there was NotPetya and its impact on Merck Pharmaceutical. Merck won a $1.4 billion judgment. That's billion with a B, not million. A $1.4 billion judgment against Zurich, their insurer. Because Zurich tried to, I won't go into the details, but the point is, that's a lot of money. That's a lot more money than the insurance companies were taking in for premiums. This is one of the factors why this has all changed. I was talking to Munich Reinsurance. They're saying, they're preparing for cyber catastrophes where multiple sites get hit with very big costs. It's more complicated than hurricanes, but it is. It's a space where they need a large pool of money somewhere that many insurance companies can draw on. It's a bigger problem than any one insurance company can manage. It's a big deal.
Interesting. All right. With that, I'd like to welcome anyone in the audience, if they have a question, to head to the mic. And if there are no questions, I have another question. So no pressure. But if anybody has any questions, now's your time. Oh. I feel people are coming. Great.
Yeah, I have one question. I'm going to coin an acronym. OT is OS. Operational technology is old school. And I'm curious, how would you see the recruitment? Do you take engineers and make them become cybersecurity people? Or take cybersecurity people and make them become engineers? Because when there's a problem and you're in front of the judge, the engineer knows more about the device than the cybersecurity specialist.
Okay, simple answer, yes. I'm serious, the answer is yes. You need both. And if you don't have both, you're missing the point. Because you'll need both complementary perspectives. And you need as much diversity as you can get, because your attackers are not like you. They're going to be different, and they're going to think different. So you want as much diversity and background, and bring people in that are engineers, but also bring people in that were scientists or from wherever. As long as there's a passion to do this and do it well, bring them in, because they're going to think differently.
Let me add to that. In my experience, it is easier to get engineers up to speed on security and really enthused about coming up to speed on security than it is to go vice versa. And this is because, old school, you're right, a lot of now it's different in aircraft manufacturing versus power plants. When, you have truly unacceptable consequences of compromise, the engineers tend to be very cautious. They want to use 5- and 10-year-old technology because it's well understood. Its failure modes are well understood, and you have to do that for safety critical systems. And so often the IT people, some of the IT people will see coming over to OT as a step backwards. The good news is there's 50 times as many, roughly, IT people as OT people. You will be able to find IT people who are enthused about coming over into the OT space. So yes, do both.
And isn't there, I'm asking this to my two co-panelists, isn't there also somewhere where it makes sense also to have an engineer, where an engineer has liability? They actually have the power to sign on solution,
Right,
and
like a PE.
Yeah.
Yeah, and they have basically an engineering stamp that says that they've actually looked at the solution. Yeah, especially within safety design as well. So yeah, that is important. And in any of these systems that are critical, they're going to have that involved. Yeah, which goes back to another piece of the cyber-informed consequent engineering, which you basically do both. You do all the digital stuff, but you underpin it with safety engineered stuff at the same time that's physical. So just, it's more expensive, but man, it sure is better.
Yeah, good to have two parachutes there.
Right, belt and suspenders.
All right, next question.
Andrew mentioned minutes ago that there's like a 1 to 50 ratio in between IT, cybersecurity specialists, and the OT. And I've heard like process safety management, pressure release valve. And it's the kind of thing you get to know once you worked in an oil terminal or refinery or maybe even an electrical switchyard for the equipment. Our private sector industry, the big players, the Chevron, Exxon, LyondellBasell, Mid-Energy, aware that they're maybe part of the solution at training OT cybersecurity specialists, or there is no such trend as of now, because you don't get this background in academia by no means as of now. So do you see any changing trends, or they're just working for themselves as of now and not maybe collaborating to the OT security community? What's your bet?
I think the unfortunate reality is we're all cannibalizing each other for talent, just because it's not an easy thing to learn. IT security, the principles, the body of knowledge, it's well established in 30 or 40 years. The IT side, the IT SMF and ITIL, we know how to manage IT well. We also know how to manage OT well. The skill sets on the OT side are going to be a little different, talking about where that valve is, right? Knowing all those extra things. The talent pool is bigger on the IT security side, but that's a difficult one to answer. It just takes experience in the field in a lot of cases. So your training is basically on the job. You don't really go to a university to learn this. You might be able to go to like the SANS Institute or some other areas that train you in industrial security, but you need hands-on with the equipment to really earn those stripes, right?
And I'll go back to my former statement. We need corporation to set up mentoring processes and apprenticeship so that we can actually bring those people up to speed and make them be the difference for the next generation coming in and taking on those jobs. I agree that a lot of time companies are more focused on their bottom line than on their security, but there is a way to make your case and actually build a place for apprenticeship and mentoring.
One real quick piece to add: pay them well, because if not, you're going to lose them, especially in today's economy. Pardon me. So the Great Resignation happened, and if you don't pay them, you're going to lose them, and I'm going to hire them.
I agree. So let me say that I'm from Calgary. The local SAIT Polytechnic has a 2-year program teaching technicians. The OT security space is like the IT security space. There's a wide range of skills that you need. There's the technicians who know how to do their job and follow procedures and understand enough of the problem to do that. There's the engineers who design the whole solution. There's security architects that have a different role, and so what's harder to find is the training for the higher end jobs. A lot of that happens on the job. I don't have a good understanding of the whole space, but I do have a couple of data points. One of our customers has asked us, saying, look, we have 200 sites to secure. We've got 20 people coming across from IT. They need to be brought up to speed on OT. Can you train them? I'm going, at what level? The SAIT training level, what is antivirus? Well, they know that already. No, we need them to become OT security architects. Oh, so you need the very highest level. So, and that, is hard to find out in sort of a university to go to. So the short answer is yes, it's happening, but how widely, I don't know.
All right, I think we have time for one more question.
OK. Vous avez parlé tantôt dans votre présentation de l'ingénierie cybersécurité. OK. On entend beaucoup parler du cybersecurity by design. Donc, en fait, j'aimerais savoir à quel point est-ce que le cybersecurity by design peut nous aider dans la cybersécurité, dans les réseaux opérationnels de 4e génération. Merci.
We need some translation?
So basically what he said is that you talked earlier about cybersecurity engineering, and he wants to know if cybersecurity by design can actually make a difference into designing those new version 4 industry model.
Yeah. So short answer is yes. And there is a move within several different regions, so the US, Europe, South America in particular. There's discussions in India and Asia where the products come out secure by default. So they don't come out with default passwords that you never change. They come out with a default password that must be changed. It will not operate until you change the password, right? So secure by default equipment is definitely a good move. We're also seeing things like you've heard of Energy Star. When you buy an appliance, you know how much energy this appliance is going to use over its lifespan. There's something, I hate the term, but Cyberstar. So basically when you buy the product, you know how secure it is at the point when you bought it. Granted, things change over time and your management matters and the threat landscape matters, get that, but you know what it is going in, as well as things like a nutrition label basically, or a software bill of materials, firmware bill of materials for what you're buying. So you know that if you're allergic to wheat or garlic, you can look at this and say, oh, well, I can't have this, or I need to do these things to have this in my environment based on what's inside and how to manage it. So we're getting better at this, and the secure by design as a concept is now looking at things like secure by default and basically knowing what you buy in ways that you never could before. So we're getting better at that.
And let me add, yes, but. Secure by design, a lot of people apply that term to cybersecurity. They look at the NIST cybersecurity framework and say, what do we have to do to our products, to our systems to make them more secure, more cyber secure? Whereas the security engineering discipline has a broader range of tools available. Again, where is a separate network? Is it even in the NIST framework, the EPRI approach? Where is an overpressure valve in the NIST framework? There's a broader set of tools in security engineering than there is in cybersecurity, and we need both of them. We need to take large chunks of risk completely off the table with security engineering. That's what security engineering does. The risk is gone, and then we need to apply cybersecurity to what's left, because there's always something left, the residual risk. And one of the things I hope will arise out of this, and it's still under development, but one of the things I see in our own customers is that the customers who do the most thorough of the current generation of security and network engineering are able to reduce somewhat their investment in cybersecurity, because they only need to apply the cybersecurity to the residual risk, not to the complete risk.
All right. We are just over time, but thank you for staying a little extra, and please join me in thanking our three panelists here for this wonderful discussion.
Thanks, everyone.
Thank you so much.
Thank you.
Thank you.
And we'll see you here after lunch.
Good work. Thank you.